Okay, we're looking at logarithms in this video. So if we look at something like 10 squared, that's 100. Now, if you have the 100 and you want to figure out what this mystery number was, you could do square root of 100 to get 10. If we have something like 10 to the power of 4, it's one with 4 zeros on it, and you had this number and you were wondering what this number was, you could essentially do root of 1,000 to get 10. Sorry, the fourth root of 10,000 to get 10. Now, that's all well and good if we're trying to solve an equation like this. A to the power of b equals c. And we sort of have both of these things, and we're wondering, what is this mystery number here? It also works when we've got, so we just use roots to do that. It also works if we have a to the b and c, and you've got these two numbers, and you're wondering what the answer is. We can do that, and you just like work it out. You just do the power. But what we haven't seen is if we've got a to the b equals c, we've got these two. So we've got the base and we've got c, but we're not sure what b is. And this is where we're going to use logarithms, a brand new type of thing in maths. So logarithms are naturally in base 10. And there's not really any mathematical reason for that, except for the fact that we like to count in base 10 usually. So log of 10, this would be asking 10 to the power of what gives me the answer of 10. That number is 1. So log of 10 is 1. That's the answer there. If we look here at log of 100, it would be a similar question. 10 to the power of what gives me 100? The answer to that is 2. 10 squared gives me 100. Now, logs are nice continuous functions. So if we have log of 10 is 1 and log of 100 was 2, maybe log of 50 should be, I don't know, maybe like in the middle, 1.5, 1.6, something like that. So let's check that. We can't work out log of 50 in our head, but what we can do is use a log button on our calculator. So it lives just above the S to D button here. So we can check our first answers. So log of 10 was 1 and log of 100 was 2. And if we look at log of 50, you get 1.698 or maybe about 1.70. So our guess of 1.5 was not too bad. Logs aren't linear functions, so they sort of climb really quickly early on and then slower later on. That's why it's not right in the middle. Log of 1 million. So essentially you can just count the zeros, 3, 4, 5, 6. So that would be 6. Now, one thing I should mention is that if we do, for example, 10 to the power of 6, I will get 1 million. And if I do 10 to the power of that number we just got, 1.70, I should get about 50, which is good. Log of root 10. So this would be asking us, 10 to the power of what is root 10? And if you're comfortable with your index laws, that number is a half. And log of the fifth root of 100. So this would be 10 to the power of what is the fifth root of 100? Now I can write this thing as 100, 100 to the power of 1/5, and 100 is 10 squared. So this just becomes 10 to the power of 2/5, if you like. So the answer there is 2/5. Log of 1 over 100, this is going to be -2. Because if we look at it, 10 to the power of -2 would give you 1 over 100. We can sort of just convert to the fraction there. Or if you prefer, you can go log of 1 over 100 should give you -2. Log of 0.001. So this sort of comes back to scientific notation. So we've got to think about how many times we have to move the dot left. So this looks like, well, if you wrote it as a fraction, it would be 1 over 10,000. And then it looks like it might be -4. We just got to double check. So log of 0.01 -4. There we go. Log of 1, this is 0. So 10 to the power of what equals 1? The answer there is 0. Log of minus 100, this is actually undefined. You'll notice that in all your index laws, 10 to the power of x is always positive. If you want to look at a graph, so that's probably the easiest way to get a quick idea of whether it's going to go into the negatives. If we had a graph of this, we would be after the y value being minus 100. And if you look at an exponential graph, you'll notice it never dips down into the negative y values. So it's impossible to get 10 to the power of something as a negative number if we're just using real numbers. The other thing that I might point out is that you can do graphs of log functions. We'll look at this a bit later formally, but if you go log of x, then the log graph sort of looks like the exponential graph just flipped on its sort of mirror imaged almost onto its side. But you can see there that it sort of doesn't go to the left of the axis. So if we try any negative x numbers, it won't work. Now the log graph does look like it sort of cuts off there, but it does sort of go down forever. So if I make my window maybe a little bit skinnier, a lot skinnier, we'll hopefully see asymptote down. Your calculator really doesn't want to draw this, but essentially the blue line does just go down forever. Sometimes the calculator can be a bit funny like that, but it does that, essentially. Okay. Moving on. 10 to the power of log 723 is 723. If you think about it, 10 to the power of whatever makes the answer 723. So that's sort of what the definition of a log is, would be 723, right? And similarly, if you do log of 10 to the power of 830, that would be 830. So logs and powers are sort of inverses of each other. You can think of them as they almost cancel each other out. Okay, we can do other bases as well. So we're not restricted to just base 10. So normal log, we think of as log in base 10 of x. But that's not always the case. Sometimes we can do this one. So this would be 2 to the power of what gives me 8? And the answer there would be 3. 2 cubed gives me 8. And we should be able to double check that. So I believe there's a log base button on your calculator. So if you just jump into normal calculator mode, hit F4 for math, and then you've got log AB. So that gives you log in any base. So we got 2 and 8, and that gives you 3. And we can check the next one straight away. So log of 5 and 1 over 25 should give you minus 2. And I'm hoping that makes sense because 5 to the power of minus 2 would give you 1 over 5 squared. Log 3 of 9 would be 3 to the power of what equals 9? The answer there is 2. And log 9 of 3 would be 9 to the power of what gives you 3. So what we'd really want here is root 9 gives you 3. And so that would need to be a half for that. And we can just quickly double check that. If we go log 9 of 3, we should get a half.